Hey everyone, welcome back to another week of Agile practices. This week I want to mostly cover continuous integration and continuous deployment, better known as CI/CD. This is a cornerstone of modern Agile practices, where we focus not just on how to build software, but on how to keep it running smoothly and constantly improving. Now, before we get into the technical steps of CI/CD, let's take a moment to think about how software actually works in the real world. We often think of software as something that's finished when it's released, but in reality, it's never done. Software is constantly evolving. Even when you think you've gotten through all the issues, new bugs, new features, or new needs always pop up. In Agile, we treat this ongoing evolution as a continuous experiment. Every iteration of code teaches us something new. Sometimes things work as expected, sometimes they don't, and sometimes we discover entirely new needs. That's why we can't think of software as a static product. It's something that needs to adapt and change continuously to remain relevant and functional. If we stopped evolving our software, it would eventually become irrelevant, much like how no one uses MySpace anymore. Anyone here still on MySpace? No? Exactly. To efficiently and reliably manage this constant evolution, we use CI/CD. You've likely seen that sideways infinity symbol used to represent CI/CD, and it's not just for aesthetics. That infinity loop is there to show how the process is continuous. Each step feeds into the next, forming an endless cycle. Let's break down this pipeline. It all begins with the plan phase. This is where we gather requirements, set objectives, and determine what features or fixes are needed next. Planning is all about setting the direction for the project. What do the users need? What's the most valuable feature we can add? Think of this stage as building a roadmap. It's crucial that we align the team with clear goals before moving forward. In CI/CD, planning is ongoing and feeds back from everything we've learned in previous cycles. The plan stage might also include looking at any feedback from users or identifying new issues that have cropped up during the monitor phase, which we'll discuss later. The key is that every plan phase is informed by real data and real needs. Once we have a solid plan, the next step is code. This is where the development team starts writing the actual software. But here's the important part. CI/CD thrives on frequent and small updates. Instead of building everything at once and pushing a giant release, we're working incrementally. This means that developers write small chunks of code, often daily, and commit these changes into a shared codebase. This frequent coding ensures that the software is constantly growing in manageable parts. This also helps teams catch issues early, which saves time and reduces the risk of major bugs going unnoticed. The point here is to keep code changes small and manageable so that we can track and resolve any issues right away, rather than dealing with an avalanche of problems down the line. Next, the build phase begins. This is where the written code is compiled and turned into a working application. In a continuous integration system, this build process is automated, meaning every time a developer commits code, the system automatically compiles it and checks for errors. The how here is automation. Tools like Jenkins or GitLab automate the build process. These tools continuously pull in code from the repository, build it, and check if it's functional. If something is wrong, like a missing dependency or a syntax error, the build fails and it gets flagged for the developers to fix immediately. This constant cycle of building and checking ensures that the code is always in a working state. You're not waiting weeks to find out something is broken. It's caught the moment it happens. After the code is built successfully, we move into the test phase. This is a crucial part of CI because it's where we validate that everything works as expected. Automated tests run to catch bugs and prevent broken code from moving forward in the pipeline. But how does this really work? In CI/CD, automated testing tools like JUnit, Selenium, or TestNG run tests on the code every time it's built. These tests check for things like functional errors, performance bottlenecks, and security vulnerabilities. The tests could be as granular as checking if a single function returns the correct value, or as broad as ensuring an entire feature works as expected. What's important here is that automation is key. Instead of relying on manual testers to go through the entire application each time something changes, the system runs these checks automatically. If a test fails, The code doesn't move forward to deployment. It loops back to the code phase where the issue is fixed before testing starts again. This ensures that only code that passes all checks moves forward, reducing the risk of bugs making it into production. Now that the code has passed all tests, it's ready for the release phase. In this step, the validated code is bundled and prepped for deployment. Think of this as the packaging stage. The code is now in a deployable state, but it hasn't been pushed live yet. The how here is that CI/CD systems can either automatically release the code or trigger a manual review. In some setups, this release happens as soon as the code passes the tests. This is more common in continuous deployment. In other cases, you might opt for continuous delivery, where the code is ready to be deployed but requires someone to manually approve the release. This gives more control over when features go live, especially in scenarios where releases are tied to business events, marketing pushes, or specific user needs. The important part of the release stage is that the software is now validated, packaged, and waiting for the green light to be deployed. It's like having a product ready on the shelf, just waiting to be shipped. Next, we move to deploy. This is the phase where the code goes live in production or into a staging environment, depending on the setup. In a fully automated continuous deployment system, this happens instantly once the code is ready. But how does deployment happen behind the scenes? Automation is again key here. Tools like Docker, Kubernetes, or cloud platforms like AWS automate the deployment process. These tools allow the system to push new code live without taking the application offline. With strategies like blue-green deployments or canary releases, you can even deploy code to a small subset of users first to make sure everything is working smoothly before it rolls out to everyone. This step reduces the friction in getting new features live and enables frequent incremental updates. Instead of waiting months for a major release, users get updates as soon as they're ready. This not only improves user experience, but also reduces the risks of large-scale failures. Once the software is live, we move into the operate phase. This is where the application is actively used and the team monitors its performance and stability. But how do we make sure everything is running smoothly? In the operate phase, monitoring tools like Prometheus, Grafana, or New Relic come into play. These tools track key metrics like server load, response times, error rates, and uptime. They alert the team if something goes wrong, whether it's a server crashing or a new feature behaving unexpectedly. The goal here is to maintain stability while the software is in use. This phase is all about being proactive, responding to potential issues before they affect users. By continuously monitoring the software, you can spot problems early, diagnose them quickly, and roll out fixes fast. If necessary, teams can roll back changes and revert to a previous stable version to ensure minimal disruption. Once the software is live and operating, we move into the monitor phase. Monitoring is crucial because it allows us to track the health of the system in real time. But how do we monitor effectively? In CI/CD, we use monitoring tools like Datadog, Splunk, or Nagios to collect data on how the software is performing. These tools track key metrics such as uptime, error rates, latency, and resource usage. If something goes wrong, like a spike in errors or unusually high server load, the monitoring system will trigger alerts, notifying the team immediately. The how here is continuous observation. Monitoring doesn't just tell us when things are going wrong. It also helps us identify patterns, bottlenecks, and areas for improvement. For example, if a feature is causing slowdowns or if users are encountering specific errors, monitoring provides the insight we need to address those issues. This phase ensures that the system stays healthy and allows teams to be proactive. If any issues arise, they can be resolved quickly before they impact users on a large scale. And guess what? We're right back to plan. After monitoring the system, the data we collect feeds directly into the next planning phase. Based on everything we've learned from coding, building, testing, releasing, deploying, operating, and monitoring, we now plan the next steps. This could mean identifying new features, fixing recurring issues, or improving performance based on real-world feedback. The beauty of this loop is that it's continuous. Each stage informs the next, allowing the software to constantly evolve and adapt. With every cycle, the system becomes more refined, more reliable, and more aligned with user needs. To keep all of this running smoothly, we need more than just a technical pipeline. We need collaboration between two key parts of any software organization: development and operations. This is where DevOps comes in. Think of DevOps as the glue that holds CI/CD together. In the past, development teams and operations teams often worked in silos. Developers would write the code, hand it off to operations, and then operations would be responsible for running and maintaining the software. This separation led to delays, communication breakdowns, and a lot of headaches. DevOps breaks down those barriers. It says, if you build it, you run it. This means the development team is not only responsible for writing the code, but also for making sure it works smoothly in production. Developers and operations work together from the start, ensuring that software is built with both development and operational needs in mind. This integration of development and operations speeds up the entire process. Instead of waiting for handoffs between teams, everyone works together in a more seamless, collaborative way. This reduces delays, prevents miscommunication, and ensures that both teams are on the same page when it comes to managing and deploying software. But how do we know if our CI/CD process is working as well as it should? That's where metrics come into play. In order to continuously improve and ensure that the system is functioning efficiently, we track key performance indicators throughout the CI/CD pipeline. These metrics give us a clear view of how well our processes are working and where improvements can be made. The first important metric is deployment frequency, how often we're pushing changes to production. Frequent deployments are a sign that the system is responsive to new needs or bug fixes. If deployment frequency is low, it could mean there's a bottleneck somewhere in the process that needs to be addressed. Next, we look at lead time. This is the time it takes to go from starting work on a feature to having it live in production. The shorter the lead time, the more agile the team. Long lead times might indicate that there are inefficiencies or blockers slowing down the process. Then there's recovery time, a measure of how quickly we can fix things when something goes wrong. No system is perfect, and failures will happen, but the quicker we can resolve issues, the less impact they'll have on users. Short recovery times demonstrate resilience and a well-functioning CI/CD pipeline. Lastly, we track the change failure rate, which measures how often new releases cause issues or failures. A high change failure rate suggests that the testing or validation processes need improvement. On the flip side, a low failure rate shows that the system is stable and that automated tests are doing their job in catching issues before deployment. By keeping an eye on these metrics, deployment frequency, lead time, recovery time, and change failure rate, we can ensure that our CI/CD pipeline is not just moving quickly, but also producing reliable, high-quality software. And just like every other part of the CI/CD process, these metrics feed back into the system, helping us to refine and adjust our approach in the next iteration. Now, how does all of this apply to Chapter 1 books? Well, it's not just about Chapter 1. It's about how Illyrios Digital Solutions operates with any project. Illyrios is built to handle rapid development cycles for multiple clients, and CI/CD is the core of how they do it. Whether it's the Chapter 1 books project or any other work, Illyrios uses CI/CD to drive continuous progress. For Chapter 1 books, we've completed Sprint 1, delivering basic features like book browsing, online purchasing, user accounts, and event registration. But here's where CI/CD comes in to accelerate the work. Illyrios is able to pound through future sprints by automating testing, integrating small, frequent code updates, and deploying in real time. This means that as the platform scales, the team can introduce new features like advanced search, reviews, and personalized recommendations without slowing down. The beauty of Illyrios' approach is that it's not limited to just Chapter 1 books. Whether they're working on internal tools, mobile apps, or enterprise-level solutions for other clients, the same CI/CD pipeline keeps the work moving fast and efficiently. By breaking features down into smaller tasks, deploying constantly, and using automated systems to ensure everything works smoothly, Illyrios delivers high-quality software faster than traditional development teams. It's this ability to continuously build, test, release, and monitor that gives them the edge in completing work ahead of schedule and adapting to client needs seamlessly. And that wraps up today's video. Keep learning, keep iterating, and as always, thanks for watching.